Good morning and welcome back to Sonnet Institute of Technology. My name is Bruce Malauti and I'm your instructor for the Pentesting video course. This is module 4 and we are going to talk about cryptography. Basically, cryptography is a method of turning data into ciphertext that can only be decrypted by the correct key. This process is called encryption. So when you encrypt data, you are turning it into ciphertext, and when you decrypt data, you are actually converting back from ciphertext to normal data, which will be human readable. Data that is encrypted cannot be read and doesn't make sense to you. So if I happen to give you data that has been encrypted and you don't have a key to decrypt it, that data is useless to you because you cannot read it, you cannot make use of it, you cannot access that data. It's just a piece of baggage to you. So just a little bit more explanation on cryptography. I'd like to let you know that cryptography is a huge topic in the world of information technology, and there is a separate study of cryptography, that is cryptanalysis. It's a huge topic. It involves a lot of theory and mathematical calculations. In today's world, we are using cryptography entirely for every data we use. So this particular video, I'll just cover the basics, especially the hands-on, which I can easily demonstrate in a simple lab. There are two main primary crypto systems, and that is symmetric key encryption and asymmetric key encryption. Symmetric uses the same key to encrypt data and to decrypt data as well. An example of that algorithm is Advanced Encryption System, that is AEC. Asymmetric key encryption uses a private key and or public key to encrypt and decrypt data. So with asymmetric encryption, a system has a pair key. One is public, one is private. The private key remains inside the system and is never shared. The public key is shared to all the systems that require it. So whenever data arrives and you need to decrypt it, the key that encrypted the let's say for example that data was encrypted by public key, and you need to decrypt that data with a corresponding private key. So what I'm trying to say is, if data was encrypted by public key, the data cannot be decrypted by using a corresponding public key. So you gotta decrypt with a private. So public goes with private. And an example of that algorithm is the RSA. And then we have the PKI, which is the public key infrastructure, and this type of encryption uses both symmetric and asymmetric, and it also involves the use of digital certificates. So these certificates are used to encrypt the public or the private key. And an example of that encryption is basically used in the web services such as HTTPS. And then we have one-time pads, which is the OTP, and these one-time pads, they actually add more security to authentication mechanism, and they they actually stop you from reusing the same key. So one time paid, you use the key, and once you use it, you cannot use it again. And then I just wanna explain the difference between static keys and ephemeral keys. Static keys are those which are used for a long time, and these keys are sometimes vulnerable to attacks. So if an attacker gets hold of the hash or of the key stored, he can try to brute force, and if he managed to brute force within a short range of time, he can use that key to access the data. Whereas the ephemeral keys, these keys, they are used for a short time. So if an attacker tries to brute force, by the time he cracks the key will be useless because it has expired. And then we'll talk about as well the 802.1x standard, which was implemented by the IEEE. The 802.1x, it actually protects the LAN network or the switch networks, and it performs at layer 2. So what happens is, in a switch environment, whenever you try to connect to a switch, you plug in your switch, your cable to the laptop or machine. When the system requests for DHCP and all that information, all these dynamic information will be sent to a AAA server, and you'll be asked to authenticate. So this prevents malicious users from walking into the office with their laptops and then just plugging in an Ethernet cable to an Ethernet wall socket. So once you are asked in to present your credentials, that will be your username and password, and you are authenticated. So it really helps to protect the layer 2 switch environment. So an example of that is the network access control, which is the NAC. And NAC uses some of the NAC uses the EPOL, which is extensible authentication protocol over LAN. That is the EPOL, and it's commonly used in the network access control. That is the NAC. 802.11i is a IEEE standard that protects the wireless local area network, which is the LAN, and also performs at layer 2. So an example of that is the pre-shared key, which is PSK. The pre-shared key, which is used in authentication methods such as the web, the WPA, and the WPA2. And these are used by the wireless access point, which is WAP. So what happens is, whenever you try to connect to Wi-Fi, you are asked for a pre-shared key, which is the password. So there are different, as you can see, different methods, and WAP is no longer used at the moment. So and WPA2 is the recommended one. So once you enter the correct pre-shared key or the correct password, you are then authenticated to the wireless access point. So this mechanism also prevents unauthorized access to the wireless network on the layer 2. And switching gears, let's talk about disk encryption. Disk encryption is also very useful, and we use it every day, and it's a must to use disk encryption to protect your data from unauthorized access. Full disk encryption or full drive encryption uses the asymmetric encryption. So you have two keys, one key is private and the other key could be regarded as public. And The recent disk encryption also uses TPM in storing the keys. The TPM is a hardware platform that stores all your encryption keys. So you need to consider as well that data can be encrypted in the following state. So we have data at rest. This is the data that is maybe in your disk or flash drive or in a database. That data it's stored and it's not in use. So you can encrypt that data, and there are different ways of doing that. You can do the full disk encryption, you can do the folder encryption, you can do a specific file encryption, or a specific column or table within the database. Then we have data in use. This is the data that is in RAM being utilized by running processes or applications. So that data can be encrypted as well to protect unauthorized access. Then we have data in motion. This is the data that is in the network. So we have examples like HTTPS that encrypts web traffic. Then we have IPsec that adds encryption to VPN tunnels. So we have freely available information on encryption, and I've added the links here. The first link provides you the very basic terms and explanations on encryption. Then the second link dives deeper into explanation of encryption and how it came about, its history, how the mathematical calculations are done, the vulnerabilities which have been experienced before, and how to protect yourself and all that stuff. So let's take a hawk to this site. So I'll copy that, and let's take a hawk and get there. So in my address bar, I'll just paste and then get there. So this is the landing page of the first site. If you scroll down, and you can see they describe what cryptography is, and if you scroll, cryptographic functions, authentication, non-repudiation. For example, in non-repudiation we use digital certificates. Then we have confidentiality, that is the encryption. We have integrity as well, so we use hashes, for example. So if you scroll down, you can see the explaining in detail. So let's go to the second site. I'll copy that and paste here. Okay, the second site as well talks about cryptography and in detail, its origin. So it gives you a full insight of what's happening. So you may take a visit there and learn more about the entire cryptography. So basically this is it for this video, and I wanted to introduce you to encryption and cryptography. So as I said, cryptography involves a lot of theory, and some of this theory cannot be demonstrated in a lab environment like this. So in this video course, I'm trying to stick to the more of hands-on, so that I can demonstrate some basic attacks on encryption or using cryptographic vulnerabilities. So I won't be diving into so much deep in cryptography. If you need to know more about cryptography, please do a Google search, but you can start by going to these two links which have enough information for you to get started. I'd like to thank you for watching, and I hope this has been informative. Goodbye for now.